This is from the circular motion practice problems based on the group teaching problems in College Physics 12. It's a worksheet number 5. It's a rubber stopper spun in a vertical circle. And I just solved number 4. It's similar to that, except now we're going to look at the situation where it's at the bottom of the circle. So all the same logic applies, except the forces are different in their magnitudes, in their directions, in the case of tension. So again, focus on the forces and the algebra first and worry about the numbers later, but I still have weight down. Force weight is downward. Tension is upward, and you'll see why in a moment. I'm making it so much larger than the weight. Well, I need a force toward the center to supply the centripetal force. Centripetal force is a generic term. It's a generic term for how we need something toward the to supply that force toward the center. So the centripetal force in this case is a combination. It's force tension minus force weight, which is equal to mv squared over r. So again, we're always looking at this and we're asking ourselves what force or forces are contributing to the centripetal force. What force or forces are making this object move in a circle? And it turns out it's these two forces, but they're not added because one helps and one hinders. The tension goes toward the center of the circle, and the force, weight, inhibits its motion toward the center of the circle. So now, you know that force weight is mg, so you can do that calculation. So that I'm considering force, weight known, mass, velocity, radius are known. You solve for the tension. And it's interesting to compare this with the answer to number 4, because the answer in number 5 is 12 newtons. It's much larger tension, which it has to be in order to overcome the weight. Instead of being helped by the weight, in this case it's overcoming the weight to actually provide some kind of force toward the center. So the theme continues, and the theme is draw the picture, look at the situation, and ask yourself, what are the forces in this particular situation that combine to make this object move in a circle?